Hey everybody, welcome back. We are to our final confidence interval, and this will be about the standard deviation, or variance. And what we have is something called a chi-squared distribution. Chi is a Greek letter, C. Looks like chi. And this is specifically used for standard deviation. When we're looking for a confidence interval about the population standard deviation, sigma. These graphs are not symmetric, so they don't look like a T curve or a Z curve. They are not symmetric. They actually start at 0, all of them, and they also have degrees of freedom. A few properties here. We have a chi-squared distribution is not symmetric. The values of chi-squared can be 0 or positive, so no negative chi-squared values. These are the chi-squared. The chi-squared distribution is different for each number of degree of freedom. As the number of degrees of freedom increases, the chi-squared distribution approaches the normal distribution. So we are going to find a a critical value of chi-squared. And we're actually going to find two of them. Here we have a confidence level of 0.95. That's alpha equals 0.05. And n is 22, which means the degrees of freedom is n minus 1, which is 21. And if I take alpha and divide it in half, that's 0.025. And I want to show you what this graph looks like. Here, I'm going to have, let's move this up. It starts at 0. And it's very skewed to the right. So here's my 0. And so we are actually looking for two chi-squared values, these critical values. So this gets split up. And the amount of area here is 0.025. The amount of area here is also 0.025. And in the middle is our 0.95. And what we're looking for, chi-squared left and chi-squared right. Oh, too high there. There we go. Well, we are going to have to use a table for this one. And the table is based on area to the right. So here's our chi-squared distribution. You can see area to the right of the critical value. Our degrees of freedom is 21, so we are down here. Down here at 21. And the area to the right, and to be clear, for this first one, area to the right is 0.95 plus 0.025. So 0.95 plus 0.025. So 0.975 is the area to the right for this left one. So 0.975, and I'm going to go down to the degrees of freedom of 21. So that is 10.283. And area to the right for this one is 0.025, area to the right. So 0.025, and I'm going to go down to degrees of freedom of 21. There it is, 35.479. 35.479. So those are the values, the critical values that we found here. So chi-squared left is about 10.283. You can look these up on, just type in chi-squared table, and any of these tables will come up and it'll work. This is 35.479. So we're going to do this again on the critical value of chi-squared. Corresponding to a confidence level of alpha equals 0.01, which means alpha over 2 is 0.005. Our degrees of freedom are going to be 24. So once again, I'll draw the picture. Go here. That's going to give me, once again, we are starting at 0. And this is going to be even smaller. This is 0.005. And over here, 0.005. And in the middle, 0.99. So here we have chi-squared left, chi-squared right. Once again, I'm going to go to the table. Area to the right here is going to be 0.995. Degrees of freedom is 24 in this case. So 0.995 is right there. Go down to the degrees of freedom, 24. 9.886. 9.886. 9.886. And the right one, area to the right is going to be 0.005. That's way down here at the end. Degrees of freedom of 24. So this is this last column here. And 24 is here. So here I'm at 45.559. 559. So these are our critical values. So that brings us to constructing a confidence interval. And I'm not going to do variance, I'm just going to do standard deviation because for this class we're not going to be using variance. So this is going to be n minus 1 So you see we'll need to find the two critical values as we're looking at this here. And once again, the population must be normally distributed. So the t and the z, if it wasn't normally distributed or we didn't know, then as long as n was bigger than 30, it was okay. Not okay for a chi-squared distribution. That is not going to work. So we are going to find a confidence interval for sigma. And to start this out, and I have enough room here, that's fine. So here's n is 22, which means my degrees of freedom is 21. Here is my sample standard deviation. And in this case, alpha is 0.05, which means alpha over 2 is 0.025. So I'm going to draw picture just to give us an idea. And 0.025. 0.025. And actually, this problem up here is exactly the same. Degrees of freedom of 21. Alpha over 2 is 0.025, so we're actually going to be able to use these values here for our left and our right. So this is going to be 10.025 283. This is going to be 35.5.479. And here we go. Squared over the right one, so it's kind of opposite. It's the left one, but we're using chi-squared right. 35.479. And when all is said and done, we crunch all that into the calculator. We end up with a confidence interval of 11.0017 and 20.4355. Be careful with your calculator as you type those in. I hope